Okay, everybody. Thank you very much for being here at this presentation on spinning up instances, nodes up in the cloud. My name is Luca Ravasolo. I work as a product manager at InterSystems, and I'm working with Aaron Hutchinson, our director on the big data project. So let's start this interesting session. You will find that at the end of the day, yes, okay, we're going to spin up some instances, but that's the easy part, right? Which is the for loop and spin up things. You know, what does that mean? How does that help me to work in the cloud? And the whole point of this presentation is that we're gonna talk about architecture. So sit back, buckle up. I'm gonna take you up in the cloud, and let's see how fast it goes. So the context is exactly that of a big data lake, where we have lots of data in terms of capacity, velocity, which is coming in, and therefore the compute power that we have is just not going to be sufficient. However big one single server is, we will have to spread our workload across a number of nodes. So because this conference is quite different, yesterday we've done an unconference, I'm going to start with a demo instead of having you waiting there and getting really excited about the demo right at the end. We're going to do it straight away so you can calm down and listen to what I'm saying, okay? So we switch to our humble terminal, and I'm going to, can you see that? Shall I make it a little bigger? Can you see at the back? No? Yeah, is it okay? Okay. Just a little bigger. I'm just going to connect to a server that I got here in California in AWS. And I have a little shell script here that I'm going to run, and it's going to spin up some cache instances. And of course, we want to be able to access it. So if you got your laptop here, your tablet, phone, whatever, you can. Yeah, I'll give you the IP address, and the IP address of the server is, is this guy here, 54.183.34.18. If you're interested, and we are just gonna, where's my terminal? There it is. We're just going to spin up, let's say, so we start at 5700, so 5700, 200, let's say. And off it goes. And, they spin up at about, 1 per second. So, yes, I'm cheating, okay? So I'm using Docker containers. I'm not running C-control start and all that, although, inside the container is actually doing C-control start and coming up, but, it's very fast. I don't have to wait for the output on the terminal. And so it's going to take about 100 seconds, I guess, depending on whoever else is using the server and our VPC here in the AWS in California. I've got other colleagues doing presentation using the cloud too, so. So the question is, how interesting is this? So yes, we are fast, we can do this. It's not that interesting. Well, first of all, because I'm taking 100 seconds to spin up 100. It's a simple for loop, it's very serial. It spins up one and it waits till this starts and then spins the other one. In reality, what you want to do in the cloud is to have a distributed system. And so we'll talk about this system that says, okay, you actually have 100 nodes out there, because I'm running one single node here. And when I say spin up 100 instances, they spin up the instances inside nodes, so it will take actually 1 second to have 100 instances up. So that's the interesting part of cloud. I can elastically do these things. And we're having some problem. Interesting. So let's see if the first on our list have started up. Let's check them out. Let's go and pick the IP address. Go to a browser. And let's say 57, I don't know, 150, one right in the middle, for example, /csp/sys/utilhome.csp. And as usual, the demo are never as fast as when you run them in your bedroom. But it's contacting, you can see at the bottom of my browser down there that it's contacting the server. It worked yesterday, a little slow yesterday too. Here we go. Let's try another one, maybe, let's say 195. Oh, one extra, too many ones. Okay, 151 then, just a simple one. It's slow. I would say it's the network here as usual. But the point is, we're up and running, and the performance are typically quite good. So if I do Explorer, let's have a look. Yeah, it's just our network. It's not too exciting this morning. Okay, you got the gist. It works. It's typically okay, and yeah. Let's have a look. I just wanted to do a global listing. It's taking too long. Okay. So just for your information here, we have our Docker, our 100 Docker up and running. They're all there. Okay, back to our slides then. So the context is that of big data, and therefore, the consideration, the architectural consideration we'll have are very much regarding, what is happening. So here's our friend, the monolith. This is how we've been creating, developing software and solution for the last 50 years. And what's the problem here? The problem is that I want to be able to scale to any size. And if you speak to our technology architects, if you've done benchmarking in your company, you will know that no matter how big a system you buy, even from IBM with their Power CPU, or the latest, version 4 Xeon CPUs with 18, 22 cores per socket, you're going to get some problem somewhere, some performance issues. Okay, so you scale very nicely till one point, and then maybe you have too many sockets, so you get into the NUMA effect, where CPUs are there talking to each other instead of doing work, or you go memory contention, you go block contention, you go lock contention. You might get all kind of issue, or the typical one is storage level subsystem I/O issues. We're always going to hit some kind of plateau, and even worse sometimes. The performance starts degrading. So what is the solution for a big data product for basically infinite scalability? The solution is not a monolith, of course. We're looking at something different, and therefore what we're looking at is to be able to scale in the cloud. And when I say cloud, it could be private cloud, it could be public cloud. So with the public cloud, there is this idea that I have infinite resources and I can keep spinning things up. And the fundamental idea is to scale horizontally. So although this picture is very much vertically poised, let's just make a stick in our mind to think about how am I going to go up this ladder with a massive monolith on my back? It's just impossible. It's not the way to deploy services. What we want to do instead is to deploy across a variety of technology, and the way we do that, we do it by segregating. So that little apple there, it really gives us the idea. We need to segregate, we need to separate, we need to decouple our services so they can be put in different, they can be spinned up on multiple services. So how do we do that? We need to review the way we develop software. The monolith, it really is, with the cloud era, it's really the end of the monolith solution these days. And cloud allows us this because, typically, even when we look at AWS, the hardware that they have is typically consumer hardware. The biggest machine that they have now in AWS, for example, it's 244 gigabyte, 64 cores, which it's a very powerful big machine. But we're looking at big data, and it just might not be enough. And again, one single node is going to hit some limitations sooner or later. So really, the solutions are looking at microservice architecture. as I mentioned at the beginning, we're going to look at architecture, we're going to look at concepts which are out there and they are making, making history in computing right now. So microservices are an architectural approach to distributed systems, okay, that promotes the use of finely grained services. So I have these small services, and these finely grained services have a life cycle of their own, which means I can spin one up independently of all the other services around me. And how have we come to this type of architecture? Well, if you think that a site like eBay, they had, and they probably still have 26 billion SQL query a day, and we have 24 hours in a day. So that means they had more than 1 billion queries an hour. That's quite incredible. How can any system on earth, support SQL query, that number of SQL queries? It's just incredible. So the solution really is breaking up, segregating, decoupling the services of my monolith, and starting to look at how I can independently, deploy them, because that's another thing that's linked to the microservices, the fact that I can actually then deploy them very quickly. And we already have, a history of almost 10 years now of companies that we use probably daily that actually have implemented this architecture. So, these guys can do, 20, 30, 50 deployments a day. And that's very interesting. Because then I can improve my application, I can fix my bug, and if one of my deployments of my services actually breaks, well, with the same speed by which I upload the new version, I can come back and restore the previous version. So the risk is always very minimal, versus having the monolith and say, okay, I need to do an upgrade or an update, a patch, and I need to go through a series of testing, which we obviously have to do. But then it takes 6 months to organize that, because everything has to be absolutely perfect. So the message here is that the fundamental thing that we need to look at with a big data project is decomposing the services and making sure that they can be distributed in the cloud. Microservices then, what they really give us is the agility to deliver this, independent components. And this gives us a great flexibility when we go up and deploy them. So given the cloud outlook that we have, it means that the typical architecture then is not looking after this big pet. The analogy that we have is, the monolith is the pet, and all these microservices is the cattle. And the pet is very expensive. Every time it's sick, I need to take it to the vet. I need to look after it. I've got my most senior system administrator that takes care of it. And again, is a human guy that touch my system. So I've got a risk to factor in there. I've got issues. While when we look at microservices, then all of a sudden we're looking at the full automation of the whole process and deployment. So I have no human intervention. And therefore, I can have a repeatable process that guarantees me what I have out there. The idea here is that if one of the cattle, one of the elements of the cattle died, then who cares? You spin up another one. If my monolith dies, my whole service is down, my whole application is down. So it really is, looking at a new type of architecture, which we call, cloud-native architecture. It's completely different. So what's the landscape? What are some of the key elements or key movements that we have, in the cloud-native architecture? So the idea, first of all, that I have horizontal scalability and it's infinite. So think of Amazon or Azure or Google. The idea is I can spin up as many nodes as I want. Then the microservice, as we said, this idea that I decompose my application, my business concern that I have inside the monolith into single small services that have a life of their own. Therefore, I can deploy them when I want and how I want them, and therefore I can fix them. I can deal with them independently. And of course, with this, we have the DevOps movement, the idea that I want my developers and the operation people to work together until the moment when my app is totally deployed. An interesting chart down here is telling us that all these trends, all these ideas about automating things are really come about because open source software, of course, because we're putting all the services together. But one thing that we noticed is that we have about this is a 2015 counting they did, Sonatype, one of the major repo sites that there are in the world. We're talking about 18 to 20 billion probably by the end of this year downloads the software. What does that mean? That means that there is going to be a software supply chain in the world, just like in the car manufacturing industry. It's a fantastic parallel, and maybe we need to learn, like we learned a few years ago from the Toyota process. About 80% of any car is outsourced. The standard pieces. Why would you want to invent a new brake system if you want to build the next Tesla? You go to the brake manufacturer, they're secure, they're safe, like SSH, there's a bug, there's an expert that's just gonna fix the SSH, and there's probably guarantees there. You use standard components, you assemble them together. And that it really is what's going to happen with the cloud provisioning. When I need a web server, when I need some kind of business logic in Node.js, in Java, in Golang, anything that they're using in cache, I'm just going to have used some standard component and provision them together and put them together. So what's the next step? What's the next step? If I provision all these things that are all standard, then I really need to buy into automation, really. Why shouldn't we automate the mundane? Why should I have a system administrator that goes out there and says, hey, I want this machine and I want to configure it this way? And what I'm getting at is the point that nowadays we can really provision infrastructure completely through software. That gives me a repeatable process that is just fantastic. So when I win my next deal and I got an application to sell, and I go to my trusted system administrator and I say, okay, we need a new machine, what's the spec for them? It can tell me, well, you need to buy this type of machine with the latest Xeon version 4, with this configuration for memory, with this configuration for the storage level. Let's take SSD this time. Okay, this is very interesting, but what am I going to do with this when I'm looking at distributed system in the cloud? This is not a real native cloud architecture that I'm looking at. I want to be able to distribute. I want to be able to have these microservices which we're talking about. So this is how we've been provisioning hardware, right? And infrastructure. This is an interesting slide. It makes you smile. That was a 5 megabyte hard disk delivered in the 50s. But at the end of the day, I wouldn't laugh too much, because only last year when we opened some data centers in London, we were in a co-location situation. What's the next step do you do? Okay, so I've got the space, I've got the power, I've got the security of the location, and now we need to order the hardware. Well, it's not much different from this, right? So 6 to 8 weeks later, you get your hardware, somebody needs to go there, haul it down from the lorry, bring it up, plug it in. In the meantime, during those 8 weeks, I've got time to think about, okay, so I need a system administrator for my system, for my assets. I need a network expert. Let's organize which IP address are we going to allocate, which TCP socket we're going to open, how do we configure the firewall, what about the NAT translation table, et cetera, et cetera. So this is really, last century, right? We were laughing at the slide, but really this is happening today. The reality is in the cloud, all I need to do is get my credit card out, and the second I press enter after giving my credit card out, and it gets accepted hopefully, I have the problem of the architecture design. So I need to have a team, or I need to have all the knowledge necessary to know how to organize, design, plan my network. I need my DBA that tells me exactly how things need to be installed. I mean, a system administrator needs to tune my OS, etc., etc. So the point here is that in the cloud era, everything happens, at a different speed. It's a complete different speed. But this doesn't mean that we can just jump on it, get the credit card out, and okay, I spin up a new EC2 instance. So what? The fact that you move your tarball onto the node and you install cache, I mean, you're still working the old ways. You're not really taking advantage of what is a cloud-native architecture. You're just doing what we've been doing for the last 50 years. And so we realized that all of a sudden, all that is an infrastructure provisioning process that used to take a couple of months, now it's right here in front of me in 1 second. And so I need to be aware of this, and what are some of the tools that we can use, and how do we approach this? Okay, so the little diagram on the side there is what I built a few months ago when I said, okay, so I'm going to go on a cloud, and I want to provision some nodes, and I want to decouple some of my services in different nodes. And, well, wait a minute, I need some security. So where do I put my firewall? So how do I define my security groups? And can I create more than one security group? Depends on the type of nodes. And what about the access to this machine? Do I need to create a mapping? What about the internet gateway? And how secure am I? Where's the firewall, etc.? So all of a sudden, our concern from infrastructure provisioning goes back left, right at the beginning. Right? You need to design it. And probably one person is not expert enough to provision everything, to understand the whole architecture. So what is a possible solution? Well, in 2008, a grassroots movement started, which is becoming very, very strong, and it's becoming a real modern trend that is called DevOps. And in other words, I really need to start thinking about interdisciplinary team. A team that is where I have a network expert, I've got the developer, I've got some of the operation managers, and this is the idea behind that. When I'm looking at cloud-native architecture, I need to have this team that really understand the whole package. And one of the things that we mentioned when we talked about microservices is they offer me this segregated, this decoupled service which has a life cycle of its own. However, those two circles, they remind us of the two pizzas a famous idea. My teams are small. They work on small little bit of code that we call microservices, and I feed them with just 2 pizzas. So admittedly, the pizzas in America are larger than the one I have in Italy, but the idea is you're not going to have more than 6, 7, 8 people. And I even have perhaps a business person in there that understand what the service needs to do. The developer that understand what is developing, a sysadmin that is aware of what it means to deploy in a cloud environment, that needs to understand that perhaps IP are not going to be pre-allocated. They're going to be dynamic as your service comes up. So what's the next problem? Well, I need to find out where my main DNS is. I need to broadcast that I'm this service and I'm offering this particular utility here. And so there's a concern and orchestration of operation that we need to really put together here. So just quickly, so DevOps is the idea that as a developer, when I finish, I don't throw my code over the wall and somebody else in another silos without talking picks it up, said, hey, this doesn't work now, it's your fault, and it throws it back. And it's the idea that to make this group of people, very tiny, very small groups, work together. Because actually the statistics tell us that there's a lot of finger pointing. That's just awful. That we're still in the 3rd millennium, we're still working like this. It should be different. And I think Bezos at Amazon, when he got upset with his team, is actually started to pave in the way to say you are responsible. I don't care who you are. If you're a developer, a network admin, a system admin, you're responsible from the moment that you're creating the code to the moment that the service is up and running and people are actually using it. Software is pretty useless if it doesn't actually run and does do something. So there's Conway's law when you get into DevOps movement and microservices that says fundamentally, if your company, if your organization creates a system, it typically that system typically represents the dialogue that you have within your organization. So if we work in silos, then your system that you sell is going to represent very much that. Okay. Okay, so obviously this begs the question, how we organize inside our company. You know, are we able to break those barriers? Are we able to make people work together and really create interesting architecture? This is just a little summary on DevOps. So the idea is that you know, we automate things, we work together, and you know, the sum, the end result is more than the sum of the few people, the two people work together. And literally, you see DevOps on the agenda of all the CIO that you talk to these days. It's more than just you know, a trend. It's becoming very, very important, especially when you consider, you know, the cloud and cloud native architecture, the cloud infrastructures. And an interesting thing to say here is that you know, we could think of that as a trend. But actually, when you put together, you know, microservices, when you put together DevOps, when you consider what it means to create a real cloud-based solution, it's more than a trend; it's a confluence of trends, and it's all pointed down the same path. And so it maybe, you know, I believe it's something that really is going to change the way we do computing. So cloud native architecture, so I must say microservice architecture and DevOps. The idea, as I've already said, is that every time we do something, if there is a problem, you know, really the concern goes back right at the beginning. Just like when I gave the credit card, and a second later, I've got this portal in front of me, and it says, okay, what do you want to build? And I have a lot of concern. The idea is, as soon as I start developing software and there's any problem in my testing, there is a bigger loop back that goes back right at the beginning. So I have a problem in production, okay? I don't say, oh, system admin, you are the expert here, can you just log into the system and go and fix it? No, we go back all the way at the beginning and get the team and say, hey, what did we make wrong? Why didn't the service stay up? What happened? Why did it crash? And so, you know, the idea is that the whole team review everything, we refix it, we rebuild it, we use automation, as we said, and we redeploy the service. So some DevOps tooling, but before just talking about some of the tools, it's important to say that, you know, DevOps is not just tools, it's really, you know, a frame of mind. It's a culture change that usually permeates a whole organization. So it's not just enough to have a little tool that does something for me. It's really, you know, buying into an approach to software development. So some of the tools that are useful for us in this, we have, you know, builders. You know, so I mean, we all know it's not very bright, but it's there. Yep. Like VMware. So I want to build a new image. I use VMware, for example. An interesting one could be Docker. It allows me to build another artifact that I spin up. Packer is another very interesting one because it builds anything from an EC2 to a VMware. And then we have configuration management tools, so Ansible, Puppet, all those that we know. And there's a new series of tools that are available, and they've been available for a few years, but they're becoming quite mature these days, and they actually allow us to provision infrastructure. So when I've given my credit card to my cloud provider, then I can say, hey, instead of me just spinning up and using the portal, which, you know, UI is always very slow anyway, in terms of, you know, clicking and flipping through the various pages in the wizard, I can use tools that maybe I've worked with my DevOps team, saying, okay, this is a type of infrastructure that I want. Okay, this is the VPC, my virtual private cloud that I want. These are my security groups. These are my nodes with these characteristics. And so that, you know, there's quite a few tools. Some are, you know, Apache-based open source tools. One that we like is Terraform, but, you know, there's a number of them. Some of them only support one particular cloud. So yes, if you're on AWS, you get the first one there at the top. You know, the CloudFormation obviously only works for CloudFormation for AWS, etc. But there are tools that are available. Oops. So some of you might have used some of these automation tools like Ansible and Puppet. We have the builders right at the top, we said, and we have this infrastructure, building tools. And yes, there is overlaps there, of course, and some of, especially the commercial product, are really running into offering everything for you, from infrastructure provisioning to managing to building the artifacts you're going to deploy. However, some of them are more specialized than others for particular jobs. So just be aware of that when you work with them. So the strategy that I think we have right now then for big data product in general is that we want to make sure that whatever actors intersystems are going to provide for you, together of course with your actors, which is my JVM code, my Node.js, my cache code, gets all packaged up, and through a building process we'll be able to provide an artifact, an image that we can just spin up. But as we said, spinning up just a single instance doesn't mean anything when I go into the cloud. I have a full infrastructure to architect, to design, to find a solution for. So I've got lots of other little cubes there. I've got firewalls, I've got NAT, I've got Nginx web servers that I need to factor in, and I've got load balancers that I need to design. So our artifact or your artifact when you be building is just one puzzle, one piece, an important one of course, but it's not everything I need. And so the idea is that when we declare what we want to one of these tools, then we just push this architecture up in the cloud and we're up and running. So as an example, we're going to talk about Terraform as a tool that we like quite a lot, simply because it's cloud independent. It has some very interesting characteristics. It's also open source, so you can download it from the HashiCorp company in San Francisco. So we said it's a cloud agnostic. It has a good characteristic like it's idempotent, meaning you can run the same operation, trying to create the same infrastructure 3 times. If it sees it already created, it's not going to do anything. Or if you add an extra node, then it's just going to add the extra node. So it has a state awareness of what's happening out there. You can even create little pictures out of it, of the various components. It supports variable interpolation, which means, I don't know the IP address of that node until it's created, right? And so you can say, okay, give me the IP address later when you created it, so I can use that variable and maybe, tell the DNS, et cetera, et cetera. So you can coordinate all these things. It's very interesting. So the idea here is that I declare my infrastructure. So how do you declare it? Well, they have different standards, the various tools. It could be YAML, it could be JSON, who cares? The point is I have a file at the end of the day, which means then I can put it under version control, which means when I spin up this infrastructure on my cloud, I know exactly what infrastructure I have. I know exactly what version I'm deploying on that cloud. Okay, so we're talking about the parallel with the automotive industry, right? So we've got all the standard component that we're going to call into. I want a Red Hat, I want a SUSE application, I want a cache particular version, and we're creating all this infrastructure with a particular node, with a particular artifact. I know exactly what I'm deploying, and everything is automated. So here's a quick example of Terraform. I don't know if you can see at the back, but right at the beginning there, this doesn't work anymore. The other one by shaking used to work. Here we go, it does. So it's asking me what provider. And here I'm providing on AWS, for example. It doesn't work anymore. And then later on, I'm specifying security access, okay, my VPC definition. And then down here, I'm provisioning resources. Everything is a resource at the end of the day, right? So this resource is of type instance. So I'm actually creating a node. What type of node? Well, I'm passing a variable of a particular AMI I was interested. So it was, in this case, a CentOS AMI. But not only that, I can then go and configure the type of node based in this case on AWS standards. So it was an M4, small or big. So that comes with a particular number of CPU, virtual CPUs, and memory, etc. And then right at the bottom, they say, well, wait a minute, I need storage on my database. I want a particular storage. I want S3, I want EBS, and I want to require a particular minimum number of IOPS, etc., etc., etc. And where do I mount it? okay, I want a particular mount point in my OS. You can define all this. It's just, one file or a series of files. And this is very interesting. And then you spin it up and you have your infrastructure. So Terraform allows us to do this deployment. This is all very interesting. Can it handle anything else? Yes, it can. Maybe you want to use some other tools. Maybe you want to evaluate. It really doesn't matter. The point is, we're faced with a cloud, wide infrastructure out there that is open to us, and we don't want to do this manually, typically. But as we said at the beginning, as soon as I got my credit card through, I have issues. I need to define network. I need to define security, for example, et cetera, et cetera. But those Lego there say, wouldn't it be nice to really use standard component in everything I do? So yes, Terraform is helping me a lot, but everything I provision, we've seen those 18 billion, probably 20 billion downloads in the world nowadays from Sonatype that are happening. Wouldn't it be nice to have standard component anyway, so I know how they behave? I know the expected behavior. I know the expected, security that I get with them and everything. And the answer, I think, is it's yes. There are some standard components out there, of course, those that you can download. But even in our code, we can become much more standard in the way we provision our software. So what if? Wouldn't it be nice if I was able to to provision my code with a PDF renderer, some Node.js code, Golang, whatever you have. And of course, the cache install and everything, in something that there is a solution. So I don't have library dependencies. I don't have any problem. It's very lightweight. All the cloud providers support it, for example. So with a series of characteristics that are very interesting, which makes for deployment a very easy path for us. And the answer is yes, and this is again another trend, and I'm talking about containers, Docker containers, very powerful trend, and those companies that they're highlighted at the beginning, from Uber to eBay, etc., they're all using this type of technology. Again, it's a trend. It only makes you trendy if you go into it, but we want to be not just trendy but wise in what we do. But if I put containers and automation, infrastructure automation for cloud native architecture and microservices, all these trends point in the same direction. They're not divergent. So something's happening. There's an interesting approach to architecture. And as we defined our architecture as code, the next step is, especially if I have immutable state in containers, then is to have immutable infrastructure. And I believe containers are just catalysts to the whole movement about immutability. So why would I want a human person, even if he's my best system admin and I trust him, but he just came to work this morning and his car broke down, he's upset. Why would I want to call him and say, can you log into my production system and fix it? There's something happening. That production system that you have now and your system administrator just touched it, okay, is not the production system you deployed. It's different. So what risk am I putting into that system? So that's the idea about immutable infrastructure, to avoid any risk. And if I have a problem, the loop goes all the way back right to the beginning. Where's the issue? Was it the developer? Was it the sysadmin? When they were trying to create, as a DevOps team, the solution, is a configuration, whatever it is. If I need a patch, if I need just to tune, a lock table, for example, we rebuild it and we redeploy. So of course, then we need to look into rolling updates, rolling upgrades, and this type of technologies. But that's ultimately what this new confluence of trends are pointing at, that we want something stable, repeatable, and absolutely giving us a lot more guarantees than what we do now by hand. So this image it's an interesting one because it's something that you don't hear anymore, CMP, so cloud management platform, and management is in italics because why would you want to manage anything if it's immutable? You don't manage, okay? And the idea here is that when you have 500 or 1,000 nodes up there, it's not much fun to go through a list and page through. So I have a problem with my node 375th. So I need to click, 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 and get there. How do you do management of these things? Why would you want to do that? Why would you want to waste time? So yes, we go into performance management, and I have another presentation later on today on that. But the point is, going just through a web portal in a cloud era, it just does not make any sense. Okay, I want the system to really take care of that. So what do we have? We have what we call cloud cluster resource orchestrators. Okay, so let me just explain to you what they are. Fundamentally, they know the resources that you have out there. So Mesos, for example, developed by Ben Hidman, the Berkeley University, then he worked at Twitter and he implemented it there, and then he created the company Mesosphere. It says, tell me where your bare metal is, tell me where VM is, I'm going to count all the resources that you have. And so he's created what they call the DCOS, Data Center Operating System. And then you just tell me what you want. So I want 150 nodes with 4 CPU and 164 gigabyte of RAM. And what Mesos does, it goes and counts what he has, he knows what he has, and he gives me a promise that it's going to deliver that. So he might not be able to fit some of these machines in VMs, he's going to use some of the bare metal, whatever it is. And that's what he does. So resource managers that handles, and they give me a promise that they're going to deliver what I want, and they handle everything else. The second one is Kubernetes. It's very much focused, it's very similar, but it just works with containers. Why would you work with anything else anyway? So you don't have to maintain the OS, for example, with a container. You spin up just your service, just your solution, your application with cache in it. Very interesting. And then Docker's got their own called Docker Swarm. And then it's Rancher, but as a small player. So as a summary, one single trend doesn't, you can afford to miss it. It doesn't matter, you're not going to die. But when there's a series of trends, a confluence of them coming together, pointed quite clearly towards a path, then we need to make sure that we look attentively and maybe pick up that. And with the big data project, we're very interested in that type of path. Cloud native architecture, it really is here to stay. And as we said, the truth is in the code now, so I can provision and version control everything, from my infrastructure to my node to anything I'm doing. And lastly, I really believe that the future is very much in all this automation that we'll be talking about, which is not just Ansible going provision something, but automating everything, from the infrastructure to the nodes. And what I think we're going to see more is autonomic computing, which is basically a system that are able to look after themselves, to self-heal, self-optimize. And we're going to see and hear a lot more about the promise theory. So these systems that they know where the resources are, and they're going to promise us they're going to deliver on that. The demo we already given right at the beginning, as you saw, but I think I don't have time. But I just wanted to very quickly show you what it means to work. For example, I've got like about 400 nodes here. If anything happened, how do I deal with this? Okay, so I need to make sure that I have maybe better tools to handle things, and that they can help me to understand how to manage everything. So thank you very much. You've seen 100 nodes being spinned up right at the beginning. As I said, that is not the answer. It's really understanding what cloud native architecture means. I hope it's been useful. On my slide here, I also put a link here for questions, and I wanted to say, don't let this be finished here. Carry on the dialogue with us in the developer community. We're always present there in the system. People are really following this up. So log in, and thank you very much for your time.